Okay, this video is on using R to make calculations of proportions and percentages along with percentile ranking and a variety of things that we find in normal distributions. One feature of R is if I want to communicate to you but not do a command, I can do hashtag, that's kind of a Twitterism, I guess, but I can start things with hashtag. And I can write whatever I want to write here. And it doesn't see this as an R command. On the other hand, if I wrote that, it's looking for a command, but yeah, I don't know of any command in R that starts with the goal. But anyway, as long as I put the hashtag, that's something, and it's something I'll do from time to time. But as long as I put the hashtag, that's a way that I can communicate to you on what we're actually, maybe a problem that we're working. And again, R doesn't confuse it with the command. And I'm going to use that option here because it just seems to make the most sense. Guys, this is going to be one of the shorter videos. It's going to be one of the simpler videos. Let's consider a problem like this. We know IQ scores are normally distributed with a mean of 100 and standard deviation 15. Now, some of the problems that you have worked previously would be something like what proportion of IQ scores is higher than, I don't know, let's go 112. Now, up to now, the tool that you would use on your TI-84 would be the normal CDF key. Well, the key that takes the place, or at least the command that takes the place of normal CDF and R, is called the p-norm key. And the p-norm key requires you to put in three things. First thing, we put in the score. Second thing, we put in the mean. And the second thing, we put in the standard deviation. This command will always give us the proportion of scores below. Every time it will give us proportion of scores below. Now, when we look at the question that we're trying to pose right here, we've posed, we want higher than 112. So to work this problem, we would use p-norm. We would go 1 minus p-norm, 112. 100 and comma 15. Because guys, if I just do p-norm 112 comma 100 comma 15, what I'm going to get is I'm going to get the proportion of scores below. But the area score, the area of the combined region below and above have to add up to 100%, which as a decimal is equal to 1. So I could either do this command and get the percentage below and then take 1 minus that, or I could just do 1 minus p-norm as I did up here and complete the problem in one step. Okay? I think most of you, at least I'm going to encourage you to consider this. Okay, let's do another problem. What percentage of IQ scores is below 88? Well, this is kind of the problem you hope for because there's no manipulation to it, because p-norm gives me percent below, proportion below. Percentage proportion is just all about reporting your answer differently. So the answer for this problem is 21.2%. Now, what if we have something like this? What percentage of IQ scores is between 92 and 111. Well, the way we work this problem is we have to do a difference of the percentages. Now, if you think about the percentage that I get here, what's that going to give me? That's going to give me all the area under the curve to the left of 111. Well, that's too much. I want to stop that at 92 and not include the area to the left of 92. Well, I can easily do that by subtracting that out. Now, if you get a visual on this, I really encourage you to take on a piece of paper and sketch out a normal distribution. Doesn't have to be a pretty one. And just get an approximation of where 92 is and where 111. And visualize this first part, the area completely to the left of 111, and then look at what it would be like to come in and subtract the area to the left of 92 and see what you get. Well, you're going to get exactly what we need, which would be 0.471421. Since we were asked to do a percentage in this problem, we're going to report it as a percentage. So the final answer would be 47.1%. Now, consider a problem like this. What IQ score represents the 90th percentile? Now, it works out pretty nicely if you think about it, that the question we're being asked here doesn't ask us to find something that starts with a P. And it's kind of convenient that the P norm operation really works problems in normal distributions for everything we're going to find that starts with a P. I mean, let's think about it. What are we going to be asked to find? Well, probability eventually. We're asked to find proportion. We're asked to find percentage. And we're asked to find percentile ranking. What do all four of those things have in common? They start with a P, and the P norm key is used to find the answers. Now contrast that with this problem. This problem doesn't ask you to find something with a P. It asks you to find a score with a particular characteristic that's expressed in terms of a percentile. So guys, the key that works here is the Q norm key, or the Q norm function. And the beauty of the Q norm function is it works exactly like the inverse norm function on your calculator. First thing we put, percent below as a decimal, the mean, and the standard deviation. So guys, to work this problem, we would do Q norm. Percent below, well guys, if we need something at the 90th percentile, well, that indicates we've got 90% below as a decimal is 0.90. The mean is 100. Standard deviation is 15. So guys, if you have an IQ of 119.2233, you are at the 90th percentile for all IQ scores. All right, gang. Another problem. ACT scores are normally distributed with mean of 20.4 and standard deviation 4.8. Find the two scores that Alright, it's easier for me to type than it is to speak. Evidently I'm not talented enough to type and speak at the same time. So find the two scores between which 80% of the distribution falls. Alright, let's think this one through. If we look at a distribution, a normal distribution, and think about 2 points, 2 lines if you will, 2 scores, where 80% of the distribution falls between those two values. Let's focus on finding the left value. Well, if we have 80% of the distribution that's explained between these two values, then we have 20% of the distribution, 100% minus 80%, that's unexplained. So that has to be the areas and the tails. Well, because of symmetry, I know that half of that 20%, namely 10%, has to be in the left tail, and 10% has to be in the right tail. So guys, to find the left value, I'm going to do Q norm, 0.10, 20.4, 4.8. So the ACT score that would be to the left of the middle 80% would be 14.25. Now I'm going to do the same thing to find the value to the right, and it is so tempting, and I see this all the time, for students to do this. You might wonder, Dr. Darber, why are you doing this wrong? Well, I want to point out a fact. I want to point out something. The 0.8 doesn't give us all of the area because that only gives us the center part. The focus of what I'm doing right now is to concentrate on the right score that kind of separates out the middle 80%. So if you think about it, to the left, I've got the 80%, which we're focusing on the problem, but I've also got the original 10, or the extra 10% in the tail. So guys, ultimately I need Q norm 0.90. So 14.24855 and 26.55145 are the two values that give us 80% of the distribution, the middle 80% of the distribution between these two values. All right, let's check our work. How would you do that? How could we determine whether or not this answer is correct? Let's say you run into this on the examination. You look up at the clock and you still got about 10 minutes left, and you're sitting there thinking, I wonder if this answer is right. I'd like to walk out of here knowing I got this question correct. How could we almost guarantee that these are the correct answers? Well, what about this? What if we take P norm and subtract this value? What's this going to give us? Well, it's going to give us the area between the two values. Is that close enough for you, for 80%, for you to walk out of that class, that test, feeling you got that problem correct? I think it is. Now, just because the area between those two values is 80%, how do we know for sure that that's the middle 80%? Well, we could do this. Let's take P norm and look at 14.24855, 20.4, 4.8. How much area should be to the left of that value? Well, it should be close to 10%. You guys, that's pretty good. That's pretty close. What should we get? What should we get here? 1 minus P norm 26.55145, 20.4, 4.8. What should we get there? Well, the 1 minus gives us area above. So how much area are we expecting to be above 26.55145? Well, it better be close to 10%. You guys, it is. So these two values being dead on, in conjunction with the area between the values being right at 80%, I would feel very, very, very confident in getting this problem correct. All All right, gang, let's go one more and then we'll be done. What proportion of scores from the standard normal distribution is between z equal 1.28 and z equals 1.50? Now, let's think methodically, okay? What proportion? We're asked to find something that starts with a P, so guys, I am guaranteed in some way I'm using P norm. Let's go back to what we talked about before. If we have the difference between two values, then we're going to use the difference in, the area between two values, we're going to use the difference in P norms. What else do we know? Well, we know z-scores have mean 0 and standard deviation 1. So guys, it's going to be an easy problem. P norm, 1.50, comma 0, comma 1, minus P norm, 1.28, comma 0, comma 1. So guys, the correct answer here would be, we were asked for proportion. Proportions are reported to 4 places. So our correct answer would be 0.0335. All right, gang, that's all I got. This should help you be able to work some normal distribution problems if you have access to R. See you later.